Hello everybody, so I'm Dr. Sergey Sarkisov, and today I want you to communicate to us this idea of polynomials. And even more so, we've done a lot of polynomials in the other videos I've shown, but I'm thinking about the fact that I haven't really done much in polynomial division, and maybe doing some rational function graphing. For one thing, let's begin with this idea of just division of numbers. You may think, like, why are we dividing numbers? Let me talk about this. So polynomial division, right here. What I always tell my students is this. What is algebra? Okay, so algebra, that kind of idea of algebra, that kind of Arabic term, that first book written of kind of finding the unknown. There's something you're looking for to kind of balance out a system of equations or kind of a system of something. So that was the idea. There was a book, Algebra, and it had to do with that, where you're trying to kind of balance this ratio, and it's basically how we solve equations to this day. Putting the unknown on one side of the variable and the number or the known constant on the other side. However, algebra basically to me means like there's an unknown, there's an x, there's a variable, right? And so polynomial division, and I will talk about numbers for a moment before I even do algebra, but it's kind of an extension, this algebra is to me an extension of arithmetic. I always think there's this arithmetic, which is numbers and operations and the theory of it, maybe number theory a little bit here and there, right? Which is a very deep field in itself. And one more thing is that arithmetic doesn't mean anything's easier, okay? Keep that in mind. It's just, let's say you need to know that or much of it before you can do algebra. Algebra, you have the unknown, the x, the variable, where you have expressions with x in them. You simplify expressions, you solve equations, then you begin plotting, graphing, parabolas. You can do a lot of different things with circles and lines, the y equals mx equals b, all those things. So anyway, let's continue with what I'm trying to get at is there's the arithmetic, then there's algebra, which is continuation in a sense of arithmetic, in a sense, but just an x, but the same thing. You still have division and addition. Functions you add. The one thing you can do with algebra that you don't really do in arithmetic is you compose functions, right? Putting them together step by step. That's a little different. We've done this earlier in other lessons. But, and then, I think from this, when you go to algebra, the next kind of thing that comes in is calculus. And even if you think about it, there are the three fundamental theorems in mathematics that are really, well known and huge in many ways. There are deeper levels to discuss them and derive them and prove them. One is fundamental theorem of arithmetic. And basically that has to do with like every number is made up of a unique prime factorization. That's one way to look at it. And there's some ways where that's a lemma, and then the corollary there is actually the fundamental theorem of arithmetic. Then algebra, what is the fundamental theorem of algebra? It means when it's actually talking about these polynomials. When you have a polynomial of n degree, you basically kind of like almost like arithmetic, you have a prime factorization that's unique. You have a unique decomposition into factors of a polynomial, and actually n degree will have n factors. Now they can have multiple multiplicities, which means you have not necessarily that many different factors, but altogether, if you write it out one by one, you would actually have n factors. It's a really cool, you need complex number theory to some extent to be able to factor it. I teach that in my pre-calculus classes when we get to numbers and complex numbers and whatnot. And then fundamental theorem of calculus, it actually is an extension to some degree of this, but basically the idea being, there's differentiation, there's integration, and integration is the antiderivative. It's going backwards on differentiation. Because when you change that, when you have that change of area of a curve over the little intervals, when you do the derivative of the area, which is kind of the integral, you would get the function. So antiderivative gives you back that integral gives you back that area. And so when we get an area under a curve, this is calculus, I know it's a little bit off topic, but calculus basically says that if you do an area under a curve, the antiderivative is very much the same thing. And it kind of connects this idea of even derivative and backwards antiderivative and what is an integral, and that is a backwards antiderivative. There's a reasoning and a whole deep depth of that. Anyway, there are three fundamental theorems that I'm really fond of, let's say. But let's go ahead and do polynomial division, the topic I want to discuss today. And one thing I want to do is let's do some numbers for a moment. For example, what if we divide, let's do it for fun, let's divide 2,500, okay, 89. Let's divide it by 12. They're like, really? We're just dividing numbers? Yeah, let's just divide numbers. In fact, before you've ever learned, hopefully you know how to divide these now, or maybe you don't, but when you do like third, fourth grade schooling, maybe sooner, maybe later, when you learn division, let me say this. Let's say you're a student who's never had division class, and you don't know how to do that number stuff. To me, the job of teaching you this is much more difficult than division of polynomials. Because knowing this, you basically know to some degree the division of polynomials base 10 format, and you'll see that. I'll show you the connection in a bit. All right, anyway, watch this. This, what you do is you're like, you know what? Okay, let's figure this out. Let's say this little problem A. Okay? And then it's like, all right, why am I doing this? Well, let's check it out. What you do is you actually, in a division symbol there, right? You put your, dividend, right? The number, dividend. Not everyone knows that term, dividend. And you put the divisor, and when you get the quotient and the remainder, that's, I'll show you what that even means, but let's find it. So you're thinking 12 into 25, right? Because it doesn't go to 2. How many times the most you can put in without getting over? And that would be a 2, and some of you are familiar with that. But this number to find it's really tricky. You're basically taking away as much as possible from 25. But a 1, you're only taking 12 away. 2, 24. But if I put a 3, 36 is too big. You don't want negative, right? I'm going to put this in parentheses for now. You'll see why I'm doing it later, and subtract the whole number. We usually don't put parentheses. We understand what subtracting 24 means. But we're subtracting the whole 24 is what I'm trying to say here. 25 minus 24, oh, that's a 1. Bring down to 8, okay. 12 into 18, well, we can only do 1 time maximum, but a 1, okay. 1 times 12 is 12. Now we're going to subtract the whole thing from 18. Oh, that's 69, right? 69, 12 times what is 69? There's 5, there's 6, 5 is the only thing I can think of, right? 5. And you get 12 times 5, oh, that's 60, right? And you have minus the whole 60, remainder is 9, right? So actually, let me show you what happens. This is actually meaning that this is 215, right? And is a plus, right? 9 over 12, which is actually the remainder being 9 over 12. So this is quotient. And you're like, this numbers, why are we wasting our time? We're not wasting our time, you'll see that. Remainder, all right. So that's that. Now, let me show you something really cool. So let's take another problem, problem B. And I'm going to say, you know what? This is something new for us, probably. You haven't done division of polynomials. Let's divide the polynomial. By the polynomial, it's coefficients and powers of x, basically. For example, let's usually go in descending order of degrees. So in other words, let's do a cubic. Let's say 2x cubed plus a 5x squared plus an 8x plus 9. Some kind of polynomial, cubic polynomial, right? And I'm going to divide it by let's say, x plus 2, a quotient, right? So this is numerator, this is denominator. One side topic, I'll erase this, but watch this. Probably erase it. Anybody know what this is a symbol for? This is a symbol for basically fractions. And these are what? This is basically the symbol for actually rational numbers. Okay? Rational numbers, right? So, question, why Q? That's a symbol, kind of a Q with a bolded Q. Because quotient. Quotient, you're dividing one over the other, right? So if you have an integer over an integer, unless you're divided by 0, don't divide by 0, you have a quotient of numbers. That's a numerator or denominator. That's fraction, right? Like 3/4, negative 17/5. Rational number that it is. Okay. So anyway, let me go back to this. And we're dividing, let's say numerator, denominator. So how do we do that? Well, let's learn how to do that. Let's do a little different color, polynomials. It's problem B. Let's put it here. X plus 2 is the divisor. The dividend, again, not everyone knows that term, right? It's right in here, into the division symbol. 2x cubed plus what? 5x squared plus 8x plus 9. Okay. Let's see what happens. X plus 2. All right. What's x plus 2? How do you cancel all this stuff? Think the same way as you did numbers. How do you get from x to 2x cubed? 2x squared. This times 2x squared will give you 2x cubed. So put the 2x squared over the x squared. 2x squared, okay? 2x squared times an x is 2x cubed, yeah. 2x squared times an 2 is a plus a 4x squared, right? Kind of, this times that, this is this. I'm going to subtract. See how I multiply that? I put it here, and I subtract the whole thing from the top. Okay? What happens? This goes away. That's what our goal was. 5x squared minus 4x squared is 1x squared, right? You minus everything. Well, then bring down the 8x. Okay? All right. How do you get from x to x squared? It's an x, right? 1x. So if I put 1x, x times x, yeah, it's x squared. That's how you divide division, long division of polynomials. This is actually long division, everyone. So let me say this is long. The blue, it's kind of marker's getting a little division. Can y'all see that? It's a little harder to see. Let me get another blue marker. This is long division. Long, the most important words here. And because it's long and time consuming. So you have, look, x times x is x squared, x times 2 is plus a 2x. Okay. Now we're going to subtract the whole thing from the top. And what's this? This goes away. Good. That's what we're trying to do. Cancel some stuff. 8x minus 2x, that's a 6x. Oh, plus 9. 9 comes down. How do I get from x plus 2 to 6x? Like a plus a 6, right? Okay. 6 times x? 6x. 6 times 2? 12. Subtract the whole thing. This goes away. Oh, 9 minus 12. That's a negative 3. Remainder is negative 3 here, everyone. So what do we get? We got the answer to be, let me show you, 2x squared, the whole polynomial. Actually, let me write it. Let me write it the way that we would actually, let me do a little different color because I know it's a little hard to see with this marker. So we got, everyone, let's write it here. See here? Okay. I'm going to say, you know what I did? 2, that's not going to work. All right. Let's do this one. On the side. So it's markers, you know, that's how it goes. So 2x cubed plus a 5x squared plus an 8x plus a 9. Divided all that by x plus 2. You know what we got, everyone? Quotient, 2x squared plus x plus 6. And what was the remainder? 3, a negative 3. So plus a negative 3, you can do minus 3 over x plus 2. Okay? And it's messy there. Now, you see something interesting. It's a little different than numbers, but very similar. If you put x equals 2, x equals 10, we're in a decimal system, 0, 1, 2, all the way to 9. They're what? They're 10 digits, or decimal system. So let me tell you what this means. If x equals 10 for a second, let x equal 10 for a moment. Okay. What is 9? It's 9. What is 8x? It's 80. So 2, 10 cubed, put an x equals 10 plus 5, 10 squared. Plus an 8 times 10 plus 9. I'm not going to give an example, but I put like a 7 here. It would be a lot easier actually looking. Or actually, if I put like a 7 here, okay, where it would be a little, like no negative, you can see it's kind of cool. It would be a little different. Yeah. But anyway, what happens, let me show you. I put like a 5 here or something. Usually in class I do another problem. So anyway, look at this. You have this. This is what? 9 plus 80 plus 500, 5 times 100, plus 2, that's 1,000, 2,000, okay? So we read this number as 2,589, 2,589, right? We divided it by 12, right? X plus 2 is equal to 12. We divided 2,589 by 12. We did that here. We got 215 and 9 twelfths, right? Here we got 216. You couldn't have it. I could have done a 215 if I did a little different number, the same, matching it up here, okay? But I gotta, put this 10 in here, watch this. 200, it's cool, right? Plus a 10, plus a 6, and minus a 3 over, that's gonna be 12, right? And so it's 216 minus 3 twelfths, and that's actually equivalent to, if you think about it, 215 plus a 9 twelfths. This is based on this argument, yeah? And this stuff. That's the same as. Look at this. Cool, right? So numbers, I just keep it there. Numbers, arithmetic, and algebra are very connected. Very. Now, this can be done for any base now because we have x. We don't just have a 10. We have an x. And also polynomials, you have negative, right? You can have, that's why I want to show you a little difference. You have like a negative 3 remainder. Numbers, you don't do like negative 3. That would be weird. You actually put a 5 here so you wouldn't have a negative like we did earlier. Right, that's how you divide polynomials. Let me do synthetic division. So synthetic division works as follows. Let's do C. Same. Now using synthetic division. So synthetic, that was long. And that's synthetic. Synthetic, what you do is you take the coefficients of the dividend, the polynomial we're dividing into, 2, just remember this, 5. It's actually a lot, synthetic is a favorite of my students when they know how to do it. Yeah. This is a lot faster than long division and easier not to make a mistake. 2, 5, 8, 9, see that? If you had negative, you put negative. If you're missing a number, you put a 0. Don't forget that. You need not forget to put a 0. And then what's the 0 of this? You ask yourself, what's the 0 of that x plus 2? Now you need an easy one where you can easily find the 0. So 0 of quotient is what? Is negative 2, right? Negative 2 plus 2 is, set equal to 0, get negative 2. Put this in the box right here. Put a negative 2 here, okay? And then put a little horizontal line, give some space here, horizontal line. Put a little, and their box. This is how you would set up synthetic. You'll see what's happening here. Okay, watch this. You bring this number down, you add it down. There's nothing to add to, 2 comes down. Okay, let's multiply, this is why negative 2, you multiply by the negative 2. What's 2 times negative 2? Negative 4. You add them down. Okay. What's the 5 plus negative 4? 1. You multiply 1 times negative 2, follow that, right? Negative 2. You add them down. That's a 6. Usually you won't write these arrows when you know what you're doing. You just put the numbers. That's a 6. You multiply, what's a negative 2 times 6? That's negative 12, right? Not too bad. And if you add these down, you get negative 3. 2, 1, 6, negative 3. 2, 1, 6, negative 3 coefficients. So if you want to actually write what the polynomial is, this is a remainder. Okay. And this is the 1, the constant. This is the x, and this is the x squared term. So the answer is 2x squared plus 1x plus 6. And minus 3, so negative 3, over what do we divide by? X plus 2. Okay. Quotient, remainder, divisor. And let's just, a final little thing I want to show you with this. Just really cool. And I know we don't have too much time, but let me do this for us. All right, watch this. Let's talk about the remainder theorem. All right, let me show you an example here. So going to this idea of remainder theorem, let's begin like right here. This is idea, okay? And I'm just going to tell you, kind of think about this. I'm not going to really give you too much detail on this, but let me show you something you may understand. All right, so watch this. You see this right here? You see that, everyone? Let's copy it. But I'm going to multiply everything by this right here. I don't like it at the bottom. I'm going to multiply everything through by x plus 2. So let's do this. Polynomial. What is that? P of x, which is equal to, what is it? 2x cubed plus the way we add 5x squared. It's a good example to show. That's why I'm trying to do this. Plus 8x plus 9. And then that's equal to, on the right side, look, let's multiply everything by x plus 2. So this quotient, what is it? 2x squared plus x plus 6 gets multiplied by x plus 2, right? You see that? And then what is this? Minus 3, the x plus 2 goes away, so minus 3. Okay? So what if I asked you an interesting question, kind of silly question. What is p of negative 2? Why am I doing negative 2? That negative 2, the 0 of x plus 2, that's why I'm actually stressing that negative 2. Okay? So that's, I'm going to double underline, why negative 2? It's a 0 of actually what we're considering now x plus 2. Now, let's say we have no idea what that is, because we actually know. Already, you know the answer. It's written on the board several times right now. This number, p of negative 2, the function, like when you put negative 2 and just evaluate it, we know the answer. You can probably see it. If you're kind of clever, you already know the answer, but let's say, or if you've seen it before. Let me show you what you do. Let's do the slow motion of evaluating the polynomial. All right. What's negative 2 cubed? I'm going to do this quickly just to kind of save time. What is it? It's 2 times a negative 8, so minus 16, plus a 5 times, it's going to be a 4, negative 2 squared, 4, plus 20. And that's going to be minus a 16, and plus a 9. What is that? Negative 4, positive 4, minus a 7. That's negative 3. Okay. So what? But here is what I'm trying to get at. Plug it into this on the right side. This is the right and the left side. They're equal. Okay. Equals 2. This I don't even want to compute. It takes forever. X plus 2, what's that? Negative 2 plus 2, okay, that's 0. All right, put a negative 2 in. And minus 3. Hold up, everyone, this is 0, right? So this goes away. Oh, negative 3. I knew it was negative 3. I knew it was negative 3, everyone. The remainder theorem tells you, here's the remainder theorem. It says the following. If you want to know p of any number, okay, any number, could do 1, 7, 13, all that, the answer will always be equal to remainder. This is a remainder. Negative 3 is, you see negative? It's a remainder. It's a remainder. It's a remainder, everyone. Remainder of the polynomial p of x divided by, you see k? Put x minus k, because then k is a 0 of x minus k. Always. We see divided by x plus a 2, the polynomial, we got a remainder negative 3. And so p of the negative 2 was a negative 3. Cool, right? So as a final illustration, we don't have much space. Let me go here and let's play around with this, because this is a really cool, the board's not erasing too well. Really cool theorem, the remainder theorem. I tell the students it's a fascinating theorem. Watch this. All right? Let's mess around a little bit with it. What if I told you, okay, let's do polynomial, the one we were having. Let's call it like example star. And so D, problem D, find like little I, find P of, negative 3. What do we do, negative 2? Negative 3 equals. And find P of, let's see a fun number. Let's do like a negative 4. Let's do that. Let's do these and that's it. Okay. So I and I. Okay. So what you can do is, yes, you can slow motion things and plug it into this sometime with this polynomial. Let's do that because we can do number and it's not impossible. But you don't want to do this usually. You can just divide and put a negative 3, right? Like right there, synthetic division is faster, the same thing, and that number will be the answer. We'll do both ways just to check. So slow motion, let's do this. Negative 3, I'm just going to do this quickly for us. So slow, what's the value eating? Let me just do kind of like, let's do the remainder theorem in green and the plugging in red. So okay, P of negative 3, what's that? 2 times a negative 27, so negative 54, I can multiply stuff. 3 times a 5 times a 9 times a 5 plus 45 minus a 24 plus 9. That's equal to what? Negative 9. That's equal to negative 24. I'm getting, everyone? That's just going to be a check word. And look at this 2. Maybe I'm wrong. We'll check. Negative 4, what's that? 2 times a negative 64, negative 128. 5 times 16, 80. 8 times a negative 4, what is that? Negative 32 plus 9. All right, what is that? That's going to be negative 48, so negative 80, negative 71. All right, and it's kind of messy numbers, and you see, I could make a mistake. I probably did, maybe. We'll see. Here's what we're going to do. Ready? Same thing. We're going to divide. It's a remainder. That's it. We want the remainder theorem. We want the remainder, so divide by. Polynomial, ready? Let's do synthetic division. I don't want to do long division, it takes forever. What's a 0? Negative 3. You'd actually divide by x plus 3 if you do long division. Coefficients 2, 5, 8, 9. 2, 5, 8, 9. And we'll do with a negative 4 also. 2 down, 2 times negative 3, negative 6. We're practicing synthetic anyway. Add them, negative 1. Multiply them, 3. Add them, 11. Multiply them, negative 33. What is that? Negative 24 it is. Cool. Okay, you trust me? Let's check it out. Let's see if we get the negative 71. So put a negative 4 in, and you can do it with fractions, anything actually. So let's do 2, 5, 8, 9. And I'm guessing what number are we getting right here? Better be negative 71 or I messed up somewhere. 2 down, put down, 2, negative 8, negative 3. What's the negative 3 times negative 4? 12. Add them up, 20. What is that? Negative 80. Oh, that's negative 71. Cool. And with that, I will end this lesson, and we continue a little bit further with polynomial division a little bit more extensively. So if you, for example, have x squared stuff, like x squared plus 2, you do want to do long division. Synthetic is very difficult. There's a trick to it, but it's like a double kind of, it makes it even tougher, I think. So, and it depends on what the x squared plus what or minus what is. All right, everybody, thanks for being here, and have an amazing day.